Hi guys, welcome back to my channel. As promised in my previous video, I will be solving a grade 12 circuit problems. So the second problem you can see here has got an EMF of 9 volt and also internal resistance R. The internal resistance of the circuit is R. And remember that internal resistance is only applied in grade 12 circuits problem. So also here we've got three external resistors. We've got one of the resistors is 11 ohms, and then one of the the second resistor is also 11 ohms, and the current passing through this resistor only is 0.2 amperes. This is the current passing through this resistor only, and then we've got this resistor here, so it's 5.5 ohms. So we've got three external resistors. The switch S is what is closed, and I have already defined the term internal resistance in my previous video. And then also let us look at what we have here. We also have got our this is the resistor here. The first question, I'm sure now the question paper is the question paper is appearing on your screen. The first question requires us to calculate the current passing through this resistor. So we have got rules that you must use when solving circuit problems. The first one is that the voltage of this resistor and this resistor are the same. The voltage passing of this resistor, 11 ohm, is also the same as the resistor of this the voltage of 5.5 ohm resistor. So why? Because they are parallel. But what is not the same in these two resistors is what is the current. Here the current is 0.2 amperes. Here the current the total current is here because there is only one path here, and then here the total current, some of the current is passing through 11 ohm resistor, some of the current is passing through 5.5 ohm resistor. Here the total current is passing through here because there is only one path. So whenever there is only one path, this is where the current meets. So remember, this is the voltage used to overcome the resistance of this resistor is the same as the current used to overcome the voltage of this resistor. And now the resistance of this resistor, I mean the voltage are the same for the both resistors. Now let us calculate. The first question requires us to calculate the current passing through 5.5 ohm resistor. So we can calculate the voltage first. I'm going to calculate the voltage passing through this resistor. So with this resistor, I know the current. The current passing through that resistor is what? 0.2 amperes. And then the resistance of that resistor is 11 ohm. So what do we do here? We apply Ohm's law. V is equals to I R. So we now want to find the voltage. Then we say V is equals to I. What is the current? 0.2. The current passing through that resistor is 0.2. And then also we've got the resistance. The resistance is 11 ohm. So let us find the voltage of the parallel connection. Now we have got 0.2 times 11, which gives us what? 2.2 volts. Very, very important. Now let us proceed to our to our second question, 2.2.2. I really love this question because it involves more calculations. Or before we pass, sorry, I'm not done with the first one. Then let us solve the first problem first. We have found the voltage of this resistor. So the voltage of this resistance also is what? If we had the voltage, it will also measure 2.2 volts. So the voltage is the same. Now I know the voltage of this resistor. It is the same as the voltage of this 11 ohm resistor. Now I want to calculate the current passing through this resistor. Now let us proceed. We have got we are going to calculate. It means that the marks will be just it won't be 3 marks. Some of the marks we are still proceeding with the question. Then I have got the resistance. The resistance of that resistor is 5.5 ohms. And then from there, I have got the what? What do I have? I have the voltage now. I know the voltage is 2.2 volts, but I do not know the current. The current is equals to question mark, so I'm just giving you question mark because I don't know what it is. Then I proceed. V is equals to IR. This is Ohm's law. Very important equation whenever we're dealing with circuit. Then I've got what? Voltage. What is the voltage there? The voltage, or we can just start by making I from the formula. We're going to have R divided by R divided by what? Divided by R. And then we have got I is equals to V over what? Over R. Let us continue. Now the current is given by, we're just proceeding with this question. Voltage is 2.2 over what? The voltage is 2.2 over 5.5. Now we are looking for the current passing through this resistor. I is equal to 2.2 divided by 5.5. Let us see. I'm going to give you the final answer in two decimal place. We have got 0.4 amperes. So of the total current, 2.2 is passing through this resistor, and then 0.4 is passing through this resistor. So the answer is 0.4. The current passing through this resistor is 0.4 amperes. So that is the answer. Then there is also another way to go through this. So we have to use the ratio equation. We have to use the ratio equation. So I'm going to the ratio method. I'm going to show you how we can still find this 0.4 amperes using the ratio method. Now let us see. The answer here for the current is 0.4 amperes. Now let us see how we can find that current without finding the voltage. Now let me show you how it can be done. Then we have got we are still answering the question. I think no wonder why it has got 3 marks. There is an easier way of doing this. Then we have the total current. The total current. Now let me add the voltage. I'm going to divide by the total voltage. I need the current passing through here, and then we have got the let's find the total current using this the ratio here. So 11 plus 5.5 is equals to what is the answer? Is 16.5. 16.5. And then the current passing through here can be obtained by we've got a 5.5, the ratio. So the ratio are just the opposite, because most of the current, at the division of the current, most of the current will pass through 5.5 ohm amperes rather than 11 ohm amperes, because this one has got a bigger resistance than this resistor. So from there, and then to find the total current, and then we have to multiply by the total current, multiply by I total current, which is equals to the current passing through we got 0.2 amperes, as you can see. Now I want to find the total current. So if I wanted to find the total current of this resistor, I would use the ratio. This is the total. So I added 11 plus 5.5, so I got 16.5, and then I used this resistance here as the numerator, so that I know that fewer current will pass through here, and then the current passing through here happens to be 0.25 amperes. Now I'm just going to 0.2 amperes. Then now I'm just going to rearrange this. I've got I total. The total current of the circuit is equals to 0.2 times 16.5 divided by what? 5.5. This actually gives me the total current. Now I have got the total 0.2. I'm just going to quickly use the calculator. 0.2 times 16.5 divided by 5.5. The total current in my circuit is 0.6. Total. The total current is 0.6 amperes. This is a ratio method, and what I can advise you is that Whenever you use a ratio method, be sure of your mathematics. It's quick, but you have to know the trick. And then I know that the total current passing through my circuit is what? Is 0.6 amperes. Now, let me find the total current passing through here. And then, of the total current, I total is equals to I total current passing through 11 ohm resistor plus the current passing through 5.5 ohm resistor. And then we proceed with this. Total current is 0.6 amperes is equals to total current the current passing through 0.2 or 11 ohm resistor is 0.2 amperes plus 5.5 amperes. The current passing through here, we are looking for it this time around 5.5 ohm. Then I just rearrange. This one comes here. I've got I, the current passing through 5.5 watts resistance. Resistor is 0.6 amperes minus 0.2 amperes, and then the answer is 0.4. I have 0.4. I have just given you two methods of finding that current as we have been solving this circuit. You have to practice a lot, and you have to master your mathematics, especially if you want to use the ratio method. So besides that, there is also the other method you could use, but at least be sure of what you are doing. These circuit problems require more practicing. So this is the first problem. The second problem, it is my favorite. Now the second question requires us to calculate the internal resistance of the battery. The question had 7 marks, so it means that there is a lot of working that we need to do. So what I like is that in our previous question, we already calculated the total current in the circuit, and it was found to be 0.6 amperes. So we have already calculated the total current. It is 0.6 amperes. We know the EMF of the battery. The EMF of the battery is what? Is 9.9 volts. So that is the EMF of the battery. And then we can see what we know. We know the external voltage from our previous question. We already calculated the V. That is not the voltage passing through here. The voltage passing through the parallel connection. So let us find out what we have really if we want to calculate the internal resistance. So we do not know the V load. We don't know the V load, the voltage going to the external circuit. We have got the formula. The formula is EMF is equal to what? I R A, then R, this external resistance. Sometimes you can just be written as R external plus what? R, small letter R. We're looking for R. And then what I can do here, we know the EMF is 9 volts. The EMF of the battery is what? Is 9 volts. Then EMF of the battery is 9 volts. That is our EMF. And then we also have got the V load. But I can write this formula in this form. I can just write E is equals to, then we have got I R external plus I R. This is the total current. The current passing through the battery is the same. The current is the same everywhere. The passing through the internal resistance is the same as the current passing through the resistors, the external resistors. So current is the same everywhere. Now I want to write this one in the form of what? In the form of V load to save myself time. So I've got EMF, what? V load. So we have got V load. V load is plus what? I R. So what I want to do here next is to find this V load. How can we find this V load? We've got V load will be given by V load is given by V parallel. The voltage of the parallel connection. Remember we have found it in the first question, and then plus V voltage of this 11 resistor, which is alone 11 ohm resistor. Just going to write 11 ohm resistor, and then V load. We are looking for V load so that we can substitute it here. Then V load will be given by voltage of this resistor is equal to I total, the total current, plus R 11 ohm, then plus 2.2. I think I have, let me just write this correctly. And then we have got V parallel. The voltage of the parallel connection is 2.2 volts plus the voltage of this resistor, the current passing through. Let me write I and R 11 ohm resistor. Then we have got V load. V load will be given by 2.2 volts plus current is 0.6 total current plus what now? Plus 11 ohm resistor. So we've got V load. Let me just give you the total answer of V load. The voltage going to the external circuit is 2.2 plus what? Plus we've got 0.6. We've got 0.6. 2.2 plus 0.6 times what? Times 11. Times 11. What do we have? And then we know that it's 8.8 volts. Remember, the external voltage V load can never be bigger than what? The EMF of the battery. So you see, the EMF of the battery is 9. The V load is what? 8.8. So this shows that the answer is what? Is correct. Then we got what? EMF. Let me just get the what? EMF. I want us to get this external resistance as we are required to do. We have the total current is 0.6 what? Amperes. 0.6 amperes. I'm going to put it here. And then we have got the V load. I just calculated it, 8.8 volts. And then we have got the EMF. EMF is 9. Let me just substitute everything in this formula and then check my R. I've got 9 volts. Then units are only important if we have to put them in the final answer. So I just got 9 volts. I'm just going to put 9. V load is 8.8. And then what? Plus the current, total current is 0.6. And then we have got multiplied by what? R. And then we just have to bring this R here. It's 9 minus 8.8. Then we is equals to 0.6 R. 0.6 R. We can also, then we are going to get 0.2, which is equals to divide by 0.6 R divided by 0.6 divided by 0.6, and then we divide by 0.6 to out. And then let me write the answer for that internal resistance. I'm dividing 0.2 and then divide by what? 0.6. 0.6. We find the answer. The answer is what? The answer is 0.33. 0.33 what? Ohm. And there are figures that shows you that the answer is correct. As you work on more problems, you will find that the internal resistance of the battery is usually just a small figure. It's usually less than 1.2, something like that. It is usually a very small number. So that is the internal resistance. Also, the V load, the total voltage of the battery is 9. The EMF of the battery, total voltage, of course, is what? Is 9 volt. And then we have got a small drop of the voltage. We lost some of the voltage. This is V lost, actually. This is actually V lost, because V lost is V lost. V lost sometimes is called V internal. Is called what? Is equals to IR. As I have shown you in my previous video, EMF is given by what? V load is equals to V what? V lost or V internal. So V lost is what? So 0.2 volts has been used to overcome the internal resistance of what? Of the battery. The last question from this circuit state that what will happen to the ammeter reading when this voltage, this resistor 5.5 ohm resistor is being removed. What will happen to the ammeter reading? So let us remove that resistor. It has been removed. I'm going to try to draw that circuit without that resistor which has been removed. So what will happen to the ammeter reading? So notice a change when I have removed this this resistor. Notice a change. You see that now this ammeter reading is now measuring the total current. This ammeter reading is now measuring the total current. At first, when there was the other resistance, here, the other resistor, it was measuring the resistance of the total, was measuring the resistance passing through this 11 ohm resistor only. But this time around, the current passing through this resistor is the same as the current passing through this resistor. Reason they are what? They are in series. So that is a huge change after I have removed that resistor. So there is only one path there. There's only one path. So, and also to calculate the resistance of the external circuit this time around, I have to use, I have to say 11 ohm plus what? 11 ohm, which gives me 22 ohms. But when I was still having a series connection, I would use this. I would also, the formula for the parallel connection, when I was still having this other resistor, was what? Was R, let me say, it would be 11 ohm times 5.5 plus what? Plus 11 ohm plus 5.5 plus 11 ohm. So as you can see, the answer here will be smaller than the answer, which means now we have increased the resistance. We have increased the resistance. Just for curiosity purposes, we can show you that now the resistance has increased. The resistance of that circuit is what? Has increased. So if the resistance has increased, what happens to the current? So that is what we know. Total resistance increase. As you can see here, it increases to 22. From when? It increases from let me just quickly 6, 7 ohm to what? 22 ohms. So if the resistance increase according to Ohm's law, what must happen to the current? Ohm's law, R is inversely proportional to what? To the current. Resistance is inversely proportional to what? To the current. So if resistance increases, the current does what? Decreases. So current decreases. So current decreases. Or we can just specifically say a reading on what? On ammeter A. Reading on A what? Decreases. Reading on A decreases. Why? Because total resistance of the circuit is what? Has increased. So that is all we have in this circuit. So what I can tell you about circuit problems is that they require more practicing so that you can get the answers right. So I will see you in my next video as we solve more electrical circuit problems.